Hello students, this is Anjana from Computer Science Department. In the previous class, we have discussed about up to half adder and full adder circuits. So, about the half adder and full adder circuits, we have discussed we have discussed up to whatever we need. We have discussed. Now, let us see what are the what are the remaining things in detail. So now let's get into our topic. We have discussed the combinational circuits and about the combinational circuit block diagram, classification of combinated circuits, characteristics of the combinational circuits, and about the half adder and the block diagram of the half adder, and about the full adder and the circuit diagram of the full adder. Up to here we have discussed in the previous class. Now let us see what is a half subtractor. Okay, half subtractor is a combination circuit with two inputs and two outputs. If you are here with the half subtractor, what is the arithmetic operation that we are going to perform is here. What is the arithmetic operation that we are going to perform is that we are going to perform the subtraction. Okay, that is we are going to find out the difference between two values, or we can perform the borrow operations. Okay, this is the combinational circuit with two inputs and two outputs. Okay, and next one, it produces the difference between two binary bits at the input, and also produces the output to indicate if a1 has been borrowed, and the subtraction a minus b. A is called as a minuend bit and b is called the subtrahend bit. Okay, so it produces here this half subtractor combinational circuit mainly produces the difference between two binary bits at the input and also produces the output. What are the differences between two binary inputs? It will produces the output to indicate if one has been borrowed. If something one has been borrowed, then it is sure to indicate. And in case of addition operation, what are the outputs that we'll get? The sum output and the carry output. Here, in case of the subtraction operation, the two types of outputs that we'll get is, what is the difference between two binary bits and what are the borrow that we have taken. Okay, it will show the difference between two bits, and then it will show the borrow. Okay, that is saying here it produces the difference. What is the difference between two binary inputs at the input, and also produces a output to indicate if a1 has been borrowed. In the subtraction a minus b, a is called as, we can say a as a minuend bit and b is as a subtrahend bit. Okay, go for the next slide. So this is the combination circuit for the half subtractor. For this input a, we have given the NOT gate. We have applied the NOT gate here. So this is the output of a b bar. Okay, we have already said that this is the AND gate, and this is the OR gate, and this is the AND gate. So for OR gate we are going to perform the addition, and AND gate we are going to perform the multiplication. Okay, so this is the combination circuit for the half subtractor. Okay, so for the half subtractor, in the previous slide we have already discussed the possible number of inputs is 2. So here if the inputs are 2, what are the combinations? How many number of combinations that we'll get? Definitely we'll get the number of combinations 4. So the number of here, if you have observed the number of combinations, this is 0 0 0 1 1 0 and 1 1. These are the possible number of combinations that we'll get here. So if you have observed this one, this is a difference between, it has to show the difference. If it find the difference, it has to show the difference, like if a is 0 and b is 0, the difference between the two values a and b is 0. If a is 0 and b is 1, the difference between the output of this one is the difference between these two numbers 0 and 1 is 1, and the borrow is 1. Okay, here if you want to find the difference between 1 and 0, the difference between these two numbers is 1, and we does not having any borrow. So here if you want to find the difference between this 1 and 1, the difference is 0, and here also it is not having any borrow. So this is a truth table for that half subtractor. Okay, this is the combinational circuit for the half subtractor, and this is a truth table for the half subtractor. See, if you have observed why we have used this type of combinational circuit, means suddenly if you are going to perform this type of logical calculations, it is highly impossible for a task for a person to do this type of differences. So if you combine the circuits like this, then we can perform the operations very easily without any complexity. That is without using any multiple number of circuits. We can easily use this type of, see here we have performed the AND operation, that is a plus b, and from this input, this is the not, we have applied the NOT gate here. So the second input is b bar. Okay, why? Because we have applied the NOT gate here, and next one is this is a. So for this the output is b is equal to a b bar. Okay, we'll go for the next slide. So now itself we have discussed about the half subtractor. Here in the half subtractor, the number of inputs that we will have is only two number of inputs, and the output, the possible number of combinations is 4. Okay, here now let us see about the full subtractor. A full subtractor is a combinational circuit with 3 inputs. Okay, in the half subtractor we are having 2 inputs. In the full subtractor we are having the 3 inputs and the 2 outputs, D and C. What are the inputs that we are having here? A, B, C, and the output we are having is, so see, whatever the number of inputs, that is not a matter. Here the number of output that we'll get is only 2 itself. Why? Because see, here the full adder is a combination circuit with 3 inputs A, B, C, and 2 outputs D and C. So we can say it as A is as a see, if whatever, if you are going to perform the subtraction operation, these three input also, we will get the difference and we'll get the borrow. So the number of outputs is 2 itself. Okay, so the full subtractor is a combination circuit with 3 inputs. What are the inputs here? A, B, C, and the 2 outputs, that is D and C. So from this we can say it A is a menu and B is as a subtrahend. Okay, So C is the borrow that is produced by the previous stage. Okay. So C is the borrow and D is the difference between those inputs. Okay. So the output and C dash is the borrow output. Okay. So from this full subtractor is the combinational circuit with 3 inputs A, B, C and 2 outputs D and C. We can say A as a minu and B as a subtrahend, and C is the borrow that is produced by the previous stage, and D is the difference output and C is the borrow output. Okay. See, if you have observed this truth table, these are the possible number of combinations that we are going to get here: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1 and 0, and next one is 1, 1 and 1. Okay. These are the possible number of, if we are having 3 number of inputs, we have already know these are the possible number of combinations that we will get. So this is the output: A minus B minus C. 0 minus 0 minus 0, 0. 0 minus 0 minus 1, that is 1 with borrow 1. Minus 1 means 1 with borrow 1. Okay. 0 minus 1 minus 0. Here also minus 1. So 1 with borrow 1. And next one, A 1 minus 0. See, 0 minus 1, that is 0, and next one is 0 minus 1, that is minus 1. So here the output is 0 and this is borrow is 1. 1 minus 0, 1. 1 minus 0, 1. So here we does not having any borrow. 1 minus 0, 1. 1 minus 1, 0. So here the output is 0 and the borrow is also 0. 1 minus 1, 0. 0 minus 0, 0. So the output is 0 and here we does not having any borrow. 1 minus 1, 0. 0 minus 1 minus 1. So the output is 1 with borrow 1. Okay. These are the possible number of combinations that we will get in the full subtractor. So if you have observed, this is the logical combination circuit for the full subtractor. Okay. This is the combination circuit for the full subtractor. See, this is the AND gate. This is the AND gate and this is the OR gate. So here we are going to perform the sum operation. So if you have the D is equal to A plus B plus C, and from that for that A we have taken the NOT gate. For that we will having some possible combination called AB bar plus AC bar plus BC. Then automatically the subtraction operation will be performed. For that we have set the logic like that. So we have already simplified these examples that how we are going to solve this large expressions into the small expressions by using some associative law, just like that we have already seen in the previous classes. So this is a combination circuit for the full subtractor. Okay. Next one, decoder. Here a decoder is a combinational circuit that has n input and to a maximum m, that is to n outputs. So a decoder is identical to the demultiplexer without any data input. So it performs the operations which are exactly opposite to those of the encoder. So a decoder is, from this we can say that a decoder is a combinational circuit. It is having, we doesn't know how many number of inputs that we are going to provide there. It having multiple number of inputs, and the maximum number of output is 2n. If you have given n inputs, then you will get 2n outputs. Okay, so decoder is identical to is same as a demultiplexer without any data input. So it performs the operations which are exactly to those opposite of the encoder. What is the operation that encoder is performing? That is exactly opposite operation of the encoder the decoder is going to perform here. Okay, from this we can say that a decoder is a combinational circuit that has an input to a maximum m, that is 2n outputs, and decoder is identical to a demultiplexer without any data input, and it performs the operations which are exactly opposite to those of an encoder. Okay, so this is the block diagram for the decoder. See here, it has taken just two inputs. In the previous slide itself, we have seen that if it is having an inputs, the output is 2n. So here in this block diagram, for an example, we have taken inputs. So for two inputs, the outcome will be 2 into 2, that is 4 outputs. Okay, D0, D1, D2, and D3. Okay, these are the outputs. This why we have indicated with D means this is a decoded message. So we have indicated with the D. So this is a we have, first of all, another thing that we have to keep it on mind is we have to give the priority for that output also. From the last to from the first, for whatever the output that we'll get first, we'll get the first priority to that, and next one is whatever the output that will next get, we will get that priority to, just like that we will going to give the priority. Okay, this is a truth table for the decoder. So here in this example we have taken two inputs, that is 0 0 0 1 1, sorry, this is a printing mistake, I think 1 0 1 1. So for that 0 0, the possible that is a D4. So fourth bit 1 0 0 0, third one 0 1, this is third one, no? So for that, at the third place we have to keep the 1 here. This is D2. So at the second place we have to keep the, this is D3. So at this third place we have to keep 1 here. Okay, this is the task of the decoder. Understand how we have drawn this truth table. These are the possible number of 0 0 0 1 1 0 1 1. So first we will get the highest priority, no, that is D0, D0, D1, D2, D3. So at 0th place we'll keep this one here. First place we will keep the one here. This is second place. So at second place we kept the one here. And this is the third place. So at the third place we kept the one here. Okay. This is the truth table for a decoder. And this is the block diagram for a decoder. So if you go for a logical circuit, this is a logical circuit for the decoder without using AND gate, without using OR gate. We have used, by using the AND gate itself we have drawn. So these are the possible number of combinations that we'll get here. See, that is if you have taken A, B, so A bar, B bar, A, B bar, B bar, A, B. These are the possible number of outputs that we'll get. So from this we can say that this is the logical circuit of the decoder. Okay, go for the next slide. Now let us see what is the encoder. Encoder is also a combination circuit which is basically designed to perform the inverse operation of a decoder. What are the operations that is going to performed by the decoder? For that the inverse operation is performed by the encoder. So an encoder has a n number of input lines and m number of output lines. So an encoder produces an m-bit binary code corresponding to the digital input number. The encoder accepts an input digital word and converts it into an m-bit and the digital word. So see here it produces m-bit binary code and corresponding to the digital input number. What is the digital input number that we have given? Corresponding to that it is going to generate the digital input number. So the encoder is a combinational circuit which is designed to perform the inverse operation of the decoder, and an encoder has a n number of input lines and m number of output lines. An encoder produces an m-bit binary code corresponding to a digital input number. The encoder accepts an input digital word and converts it into a m-bit and the digital word. Okay. Now let us see what is a priority encoder. It is a special type of encoder where the priority is given to the input lines. Here even for the input also we are going to give the priority. And next if two or more input lines are one at the same time, then the input line with the highest priority will be considered. Whatever the input at the first line will be considered as the highest priority. There are four inputs we are having: D0, D1, D2, D3. We are having four inputs, and two outputs we will have here, that is Y0 and Y1. Out of those four inputs, D3 has the highest priority and D0 has the lowest priority. So if D3 is equal to 1, then Y11 is equal to 11 irrespective of the other inputs. Similarly, if D3 is equal to 0 and D2 is equal to 1, then Y1, Y0 is equal to 1, 0 irrespective of their inputs. Okay. This is about the priority encoder. See, this is a block diagram of the priority encoder. Here from the beginning to ending we are going to give the priority. So from that we will get the output here. So this is D0, D1, D2, D3, just like that, 0, 0, 0, 0. Here we have given this possible number of output inputs is 0, so we does not having any output here. So here this one is 0, 0, 0, 1. Here this is the lowest priority, that is D0. So here the output is also 0. Here at D1 we are having the possible priority, then the output will become 0 and 1. And these are the possible, if you have observed, these are the possible combinations that you will get here. So this is about the priority encoder and block diagram of the priority encoder and truth table of the priority encoder. In next class we are going to discuss about this. So this is a logical circuit also, and next class we are going to what are the design of the combination circuit, just like that. So up to here we have finished about the decoder and encoder also. In the next class we are going to continue with this. Okay.